Welcome to this online course, offered by the University of Algiers 1, Architecture Department. This course is part of a series of lessons that fall within the teaching of the Design Studio subject for the Architectural Engineering specialization. Presented to you by Dr. Mansouri Khaled. The course is structured in 3 major chapters, starting from understanding the site, landscape, and slope sites, and progressing toward applying site integration strategies in real architectural contexts, to conducting site analysis methods and approaches. Understanding the site is a fundamental part of the architectural design process. Throughout history, vernacular architecture has often emerged directly from the site, while Greek and Roman architecture leaned more toward order and style rather than site. The modernist movement has created iconic projects with universal ideas rather than context. However, architects like Frank Lloyd Wright offered more site-sensitive alternatives. By the 1960s, the importance of context re-emerged in architecture. Today, the site is once again central to architectural conception. The first chapter introduces the concept of site, which refers to the specific location where a building, structure, or project is situated. It is not just the physical area, but also all the environmental, cultural, historical, and social contexts that influence the design and construction. In relation to the site, the landscape, it is defined as a large area of land, a set of surface entities, an object of artistic representation, the result of the actions of men adapting to their natural environment, a practices, a cultures, and a memory. We can identify site topography using topographic maps. It is a tool that helps identify the 3-dimensional shapes of a site in its natural state. It is produced at a precise scale, which varies according to the extent of the site studied. It is essential to learn how to read geological and topographic maps in order to access all the information on these maps, transform this information from the surface of the map into a vision in space, 2D profiles, 3D model, decide how best to insert a building into a relief. This course presents a detailed method to read different topographic mappings. In order to draw a site or a given terrain profile, we need to learn the different steps to make a site profile from a given maps. These steps will be detailed and practiced during this course through different application examples and exercises. Here are some examples of drawing terrain profiles from the topographic maps using the previous illustrated method. You will find and practice these cases during the course self-evaluated and peer-reviewed assignments. A slope is the measurement of a terrain steepness on a surface at any given point. Also, it is the rise or the fall of a land surface. Therefore, we can distinguish 2 types of slopes, rising slope and a falling slope. Also, flat areas are never strictly horizontal. They are gentle slopes, unnoticeable to the naked eye. The slope generally has 2 types, rising slope and falling slopes. However, slope sites has different parts that differentiate with the position and the steepness level, such as the plateau, the summit, the hill, the ridge line, the escarpment, etc., as shown in the figure. The second chapter introduces the concept of site integration, which is in general defined as a harmonious relationship between a construction and its host site and the landscape. We can distinguish 2 types of integration: perfect insertion into the landscape, or a contrast enhancing the site. Integrating a construction into uneven or a slope site follows 4 major techniques. 1. cut and fill to create a leveled surface. 2. Insertion into the ground, by creating a lower level beneath the ground. 3. Creating multiple platforms, by cutting into land, and building retaining walls. 4. Rising the building from the site, by using pillars. There are different possibilities for inserting a building into a slope. Based on the land-soil treatment, we can distinguish 3 types. Cut into the ground, level the terrain, preserve the soil and raise the building. And, based on the contact with the ground, we can distinguish 3 types: touch the ground, land on the ground, and buried in the ground. We can distinguish 3 major types of building: positioning relative to the slope, parallel to the contour lines with the slope, perpendicular to the contour lines against the slope, and a combined position of the 2. We can distinguish 3 major positioning with the surface: overlooked, at the same level; thrown, above the surface; dive under, below the surface. Integration of a building in a slope needs to consider the positioning of the access, or main entrance of the building. Therefore there are different positions: entrance from above, from below, from under, from the top, etc. The following figure shows some of the different possibilities. Integration of a building in a site means interacting with the pre-existing in that site. Therefore, to be integrated, there are different possibilities: to work with the site, to inspire from the site, to be integrated, or contrast the site. Here are some of the world's famous projects, from 2 famous architects of the modern movement: The Falling Water House, by Frank Lloyd Wright, and Douglas House, by Richard Meyer. This final chapter introduces site analysis as a part of understanding the site for an optimum integration. So, site analysis is an essential step in the process of the architectural design. It's finding the dialogue of the project with all the factors, with the intention to integrate a project into its surrounding. Its aims generally to identify the main character of the site and identify the strengths and challenges of the sites at all levels. Site analysis follows 3 major steps: read the site, by making analysis in the first instance; understand the site, in the second instance; understanding issues, and using the knowledge bases; interpretation, by proposing solutions based on your reading and understanding of the site. Site analysis uses 2 types of studies: to gather the necessary data, and to understand the site more profoundly. 1. Sensitive study, with qualitative data, by observations and senses of circulation, mobility flow, function, use, climatic data, etc. 2. Static study, with quantitative data, using statistics, graphs, to study the limits, urban composition, architecture, physical and spatial data, etc. In the end of this course, the learner will be able to conduct a deep site analysis on real given case studies, as shown in the example. Applying all the learned materials and techniques of reading the topography, integrating in the site, designing with the environment, and conducting deep site analysis. This was an overview of the course content. To access all the materials, the full course is available now at edX and Moodle. Join us.